everything. So that was something that came to my mind.
Yeah, this is a very common issue for cars because the origin of all parts is usually center front axle, and this totally breaks sorting in Unity because we sort by origin. So we have had various OEMs doing the hack where they basically set the origin of the mesh to its center.
Okay. One last thing regarding the instances. We have a tool in PiXYZ to identify automatically the instances because it's not obvious. You can't know just by looking at the hierarchy what is an instance and what is a single part. So we just have added a little function here to automatically identify the elements that are an instance and that are repeated more than X time in your model. So here, for example, I'm going to look in this break disk for all the elements that are duplicated more than 5 times. And if I execute the process, I will automatically select all the instances duplicated more than 5 times in my model. That can be very useful for car assemblies or aerospace models, where you can have thousands of these small elements available in your model. So if you don't have the name of the bolt, if you don't have the exact geometrical property you need to look for, you can just check if there is instances, and if you are looking for instances over I don't know 1,000, you will automatically detect all the small screws and everything, and just by removing them, you can gain a lot of polygons. I don't know if it answers your question, Ed, or part of maybe, but.
Yeah, I believe it does. Thank you.
Okay, I think it was everything we made for this specific model because the guys wanted to keep the ability to interact with each of the separate parts. So, and 1.3 million polygon, 28 occurrences, it's way enough for a use in Unity. They had also a little more elements in their scene, but nothing very big. So they were happy with this. I think we stayed at this level for the optimization process. Okay, I'm going to switch to another one. Yeah, maybe let's use this one. It's a very recent one. It was an interesting one. So it's a very big model. So I will check, but all the processes might be quite long. Let's check. So the 3D file is not so big. You can see here it's around 24 megabytes. So it's pretty standard actually. It's half the former model. Exactly half actually, but it's way bigger. You will see. So it's what I believe is a beam model. So you can see here it's part of a bridge. So here the scale is misleading us, but it's a very, very, very big assembly. We have something around 25 meters from end to end, and it's a 15-meter height, I think, model. And you can see that we have the details of all the I don't know, the structure of this bridge table, I would say. I don't know the exact word in English, but it's a portion of a bridge. And if we look inside, I can use the exploded view. You will see that we really have a lot of elements inside. So you have the entire structure, all the iron and, I don't know, metallic elements inside the model. So the file is not very heavy because, well, in this one, for sure, we have a lot of instances. All these small elements here in metal are all duplicated, I don't know, thousands of times. That brings us with 34,000 occurrences in the model and around 65 million polygons. So bringing this part into Unity as is would be very difficult. So let's start optimizing this one. Let's first have a look at the occurrences. So we see that we have a lot of occurrences. I don't remember exactly how was the product structure. Here you can see we have something which is way deeper. I mentioned 40 levels earlier. Here we are almost at 10, maybe 12 different levels. So this is part of